So we are, all right, guys. We're going to talk about taxonomy in general first, and then we're going to talk about the different domains and kingdoms of living things one at a time. Some will spend more time on than others, but for now we're just going to talk about what taxonomy is in general. So we have some words that we'll be using. You have the vocab to refer back to. And this just kind of gives you a little bit of an overview of, what exactly taxonomy is.
I think humans have an inbuilt need to classify the world around them. We do it with music, we do it with food, we do it with art, and that's what the science of taxonomy really does. Taxonomy is the science of naming, describing, and classifying the living world around us. Taxonomy isn't just about naming all the species that we found, it's also about ordering them, it's about grouping them together. And we group them together based on shared characteristics. So if a group of animals show shared characters, we may think that they evolved from a common ancestor, and that's why we group them closer together. The work of taxonomists is never really done. As we discover new species, or we discover more about older known species, often these names change to reflect this new information. Nautilus are one of the groups that I look after here at the Natural History Museum, and they're a really interesting group. When you first look at the shells of these species, they look very, very similar. But if you look a bit more closely, you can see some of the differences. So the umbilicus, the central part of this, varies in shape and size. And as we notice these changes, as we understand them more, then we can change the taxonomic names around them, because this gives us a better clue to their evolutionary history. Taxonomy is never really finished. We just get a step closer to the truth. When I first started working at the museum, working on the collections, I had no idea that the taxonomic work that goes on here had so many amazing applications. Things like disease prevention, conservation, ecology, food security, pest management, and even things like discovering new drugs from deep sea animals or Amazonian plants. There really is no end to the importance of taxonomy.
All right, so what taxonomy is, it's the science of how we classify and categorize and name living things. Okay, that's what taxonomy is. Okay? The science of classification. And as they were talking about in the video, sort of humans, we just put things into categories. We classify things to help us sort of make sense of the world. We know what a tree is a general principle that we have, and we can look at something and say, oh, that's a tree. And we put things in these categories that help us understand them. Okay. When we look at how living things relate to each other, when we put things in the same category, it tells us something about their similarities. It tells us something about maybe their evolutionary history, about their ancestry. We could tell a lot by putting things into different categories and seeing how they're related. Our modern system of classification, sort of the father of taxonomy, our modern system is thought to be Carl. His original name was Carl von Linn. Okay. He changed his name to Carolus Linnaeus to make it sound more Latin. He's a big fan of Latin. And Linnaeus came up with a system in which each living organism that has been identified gets a special name, a scientific name, a binomial name. Okay? And this system is called Binomial Nomenclature. What's the prefix bi mean? Two. Nomial means name. So the two-name naming system. That's what this word means. Who takes Latin? What's it say at the top of each of your papers? Where you write your name? Nomen? Yeah, so nomen means name. So this is a system of naming things in which each organism gets a special two-part unique name. Does anyone know the scientific name, the binomial name of humans, our species? No? I'm sure you've probably heard of it. Our scientific name is Homo sapiens. That's the name of our species. Every species gets a name. Outside in our courtyard, what do we have out there? Pinus strobus is that white pine tree. The birch out there, that is Betula papyrifera. What else is out there? The maple tree is Acer saccharum, a sugar maple. A red maple tree is Acer rubrum. So each species, we have our name. We might call it its common name. Okay, if I say the white pine tree, that's its common name, but it has a scientific name as well in the binomial nomenclature system. And they sound strange probably because they're all based in Latin usually, sometimes Greek. Linnaeus chose Latin as the language for taxonomy. And there's some reasons for that. Okay? Where do people speak Latin today as their everyday language?
Nowhere.
Right. So nowhere is not a modern language that's used in everyday conversation. And that's one of the benefits of using Latin. Because it is no longer spoken, sometimes called a dead language, that it stays relatively stable. If English or German or Chinese or Arabic have been chosen as the language, well, those are modern languages. They change all the time. New words are starting to be used. Words go out of use. The meaning changes. Whereas Latin is sort of a set, defined language that everyone can agree upon.
So if you use a different language, then the words you might have used to name things would...
Yeah, and we're going to talk about that. For example, if you talk about domestic dog, okay, Canis domesticus. In English, we would call it a dog. What would we call it in Spanish?
No,
Perro. How about Italian? Cane. So we might be talking about the exact same species, but we would be using 3 different words for it. Whereas if we use the established scientific binomial name, scientists, no matter what language they speak, can use that scientific name and know that they're talking about the same species. It doesn't favor one culture over another as well. So Linnaeus chose Latin. And that's why when you hear scientific names, they always sound like they're in Latin, because they are. Little taxonomy. So, good one, huh?
I can't understand it.
You say tomato, I say Solanum lycopodium. That's the scientific name. That's the binomial name for a tomato. Because if you were in Italy, you might say pomodoro. If you're in English, you would say tomato. But you're talking about the same exact species.
Maybe it's confused right now.
What? Yeah, get them right. All scientific names of all different species. Just kidding. So the other thing is that when we use common names, the names sort of that are in use in our everyday language are often misleading. What is that?
Jellyfish.
Yeah. Is it a fish?
No.
No. Is it taste delicious on toast?
Yeah, maybe.
Some people like it.
No.
Maybe.
So again, it's a misleading common name. What is this?
Seahorse.
Is it a horse?
No.
Of course not. It's a fish.
It isn't a sea though.
What is a jellyfish? It's not a fish.
Lots of pond.
Mammal.
It's cnidarian.
What?
What?
Cnidarian. How about ringworm?
Ew.
This is a skin infection people get. It's not a worm.
Oh, it isn't?
It isn't.
It's a fungus. It's a fungus.
Worms.
It's a fungal infection.
That's nasty.
Starfish?
Fungal.
Is it a fish?
No.
Is it a burning ball of hydrogen?
No, but it is a star
No.
shape.
It is shaped like a star.
Well,
So
actually,
again,
not really.
these are sort of misleading.
Dragon fruit.
Dragon fruit. It doesn't burn fire.
So some examples. You guys have seen these two characters?
Roadrunner.
Roadrunner and Coyote? Roadrunner is an actual species, Geocossix californius. And a coyote is an actual species, obviously, Canis latrans. But if you ever watch the cartoon, the introduction where they're like chasing the coyotes chasing Roadrunner, they freeze it and they show you a scientific name. Have you ever noticed that?
No.
You may not have noticed. If you ever watch it again, pay attention, and they freeze it and they show like a scientific name, but they're fake scientific names. They're made up. They're kind of jokes. Like sometimes they've called it Accelerati increditus
Oh, yeah.
or Edius birdius. Now those aren't the real scientific names for these species. They're jokes. Why do they look like scientific names?
Because they're long
Hard.
fancy.
Because they end in like Latin endings,
Long,
right?
hard to
Maybe
say.
to write those down.
No, not really. All right. So Linnaeus set up a system of classification where we have a hierarchical set of taxonomic groups, starting with very, very general, getting down to more and more specific. The most general of the groups is called the domain. Linnaeus didn't include domain as one of, this system has changed many times as scientists learn more and more about living things. But today, the largest group is domain. Every single species on Earth is in one of three domains. There's only three domains that every species. We are in the same domain as an oak tree.
Why?
Okay? So obviously, domain is a very broad category where you have many things that might not seem to be that closely related in the same domain. We'll talk about why eventually. The next level down is kingdom. Again, it's still a pretty broad group. We are in the same domain as a worm or a sponge. So that's still very broad, yes.
Sponges are
But as we move down this list, we're getting more specific. Phylum is next. Yes. Then we have class, order, family. And then the last two are the two taxonomic groups that give everything the scientific name. We say the scientific name of that white pine is Pinus strobus. That comes from the genus for that tree, which is Pinus, and the species, which is the most specific, strobus. So when we give the scientific name of something, like Canis latrans, we're telling you the genus and the species. So as we go through from domain down to species, the number of organisms in each taxonomic group gets smaller and smaller, until eventually when we get to species, there's only one type of living thing in that species. And how closely related the organisms within that group are also increases as we go down. Like I said, in domain, a human and an oak tree are not very closely related. They don't share that many characteristics in common, but they do share some. And so as we go down this list, we get more and more closely related. Dan?
So what's a race? Is a race not?
A race is sort of
A human
a
race.
social construct. Not really, it's not a group, a taxonomic group here.
Oh,
So let's look at an example to help us understand. Now, we'll start with kingdom. This doesn't start with domain. But in kingdom Animalia, all the animals, all of these things are in that kingdom together. So a grizzly bear, a starfish, all these other organisms are all in one kingdom because they do have certain characteristics in common. Well, let's go a step down to phylum. So Phylum Chordata, what is no longer in with these other organisms? Do they have? Yeah. So do you know what? What do these have in common that a starfish did not have?
On land.
They
Nope.
live on land.
Well, that is true, but that's not why they're there. Something else. What?
They have a brain.
Nope. I mean, that is true, but they're all, these are vertebrates, animals with a backbone. A starfish is an invertebrate. All right, let's go down another into class. Okay, class Mammalia.
4 legs.
Mammals. So, yeah, the snake is gone, it's not a mammal. So we're getting more and more similarities as we're going down from kingdom down to species. Okay? They're getting more and more close related, and we're getting fewer and fewer things in each group. All right, then we have order Carnivora. That has to do with the teeth. Then we get family Ursidae. This is the bear family. Okay? Then we get genus Ursus. Okay? This is a specific genus of bears. So the panda is out. And finally, we get down to species. We have Ursus arctos. We have the grizzly bear. It's all alone. It's just, that's a single species. Okay? So do you think the black bear and the grizzly bear are pretty closely related?
Yeah.
Yeah, they're in the same genus together. There are some differences, so they're different species, but they're pretty closely related.
So you can only go that way, you can't go the other way.
Well, yeah, you're getting more specific. As you work your way up, you would be getting less specific. So to remember domain down to species, there's a couple things you can do, because you are going to have to memorize that. One, there's a couple mnemonic devices people often use. One is like the classic old school one, which, I don't know, it's okay. Dear King Philip, came over for grape soup. Domain, kingdom, phylum, class, order, family, genus, and species. Not, this one's a little, you know what we'd say? Not so much inappropriate, but kind of not very nice, but it may be more memorable. Dumb kids play catch on freeway, go splat.
Where'd Bobby go? Splat.
Or the best way to remember is through a song. So let's show you this video. It was recorded by another class that was studying taxonomy.
Okay. In Mr. D class, we learned King Philip came over good spaghetti. But we gonna do it a different way, like kingdom, father, class, order, family, genus, species. Kingdom, father, class, order, family, genus, species. Kingdom, father, class, order, family, genus, species. Kingdom, father, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species.
Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species.
All right, so any way you remember, just got to remember those. People always remember the song, though. If you ask any like ninth grader, they'll remember, and they remember usually because of the song. So here are our groups. If we go down, domain, kingdom, phylum, class. What's next? Kingdom, phylum, class. See, you already remember. Let's look at where humans fit in here. So like all species, you can put them in various taxonomic groups. The domain that humans belong in. Now you notice they didn't say domain. Sometimes people don't include domain, in like an introductory class. It's a more recent addition to taxonomy. I mean, it's not that recent. It's been, 20 or 30 years. But sometimes people, they just go with the classic kingdom down to species. But you need to know about domain. And so our domain is called eukarya. We'll talk about what that means eventually. What kingdom? Animal. Now these also have Latin names. Animalia is really the Latin name for the kingdom. Phylum Chordata. We are chordates. Those are vertebrates, animals with a backbone and a spinal cord. What class?
It starts with C.
No.
Or it's
Yeah, mammals. Humans are mammals. Order. We are in the same order as apes, monkeys. You know, if you're at a zoo, which exhibit would you go to see those things? No. They're primates. Have you ever heard of primates? And then from here on down, humans are the only species in these groups. So you probably have not heard of many. Family is Hominidae. Hominids, sometimes called. Genus Homo, species Sapiens. Homo means man, sapiens means like knowing or wise. That's where the name comes from. And so that's where the scientific name for humans is. Homo sapiens, it's our genus and our species. I'll skip this one. All right. Now when we write a name in binomial nomenclature, we follow certain rules. We'll talk about those. But first, let's look at these bears. The panda bear, the polar bear, the grizzly bear. Which two are most closely related? Can you give me a reason why? Henry?
The polar bear and the grizzly bear,
How come you said that?
because if both of their first Latin names, they have verses.
Yeah, they're in the same genus. They're both in the genus Ursus. The panda is in a separate genus. So these two are more closely related than the panda. So you'll also notice when we write the scientific name, we follow specific rules. First of all, it's the genus and the species. That's what a binomial name is. We capitalize the genus, and the rest is lowercaseified. I made that word up. You cannot use it. If you do, it's 25 cents per use, payable to me at the end of the year. Operated at 10. Lowercaseified.
What's your use?
25 cents per use.
No, like what's your word though?
Lowercaseified. It's the opposite of capitalized. I also invented other words.
lower classified.
Lowercaseified. The other word I invented was, it's like aerodynamic, but in the water, it's aquadynamic. You know, something's aerodynamic, it glides through the air. Well, in the water, it's aquadynamic.
Alright, so the real only can back this one.
Did you say it? It's because the YouTube will automatically put it on your school bill by the end of the year. So anyway, the genus is capitalized, everything else is lowercaseified, and we write it in italics. You know how to print in italics?
Put quotes around it.
What?
Put
No,
quotes
you
around it.
underline.
Or you can underline.
Oh.
So if you're writing on like your computer in italics, if you are writing it by hand, you can underline.
But I like,
Italicized.
I can't see it.
Sorry, word.
Can you make up italicized too?
What's that?
You can make up
No.
italicized.
All right.
It's not italicized.
Last thing we'll talk about today. So, the definition of species is kind of a difficult one to specify. generally the biological definition of what a species is, it's a group of organisms that can interbreed and produce, there's really another part to this, and produce fertile young. Hold on. But there are instances in which two different species can mate and produce offspring. We call them hybrids. Hybrid is an offspring produced by two different species. Now, can a cat and a dog make a hybrid cat dog? No.
It would be called a cog.
They can't. They have to be closely related, very closely related, usually in the same genus. Here's some examples of some hybrids. First one is the most common. It's one that's been produced and used in agriculture for many, many years. It's if you take a male donkey, Equus asinus, and a female horse, Equus caballus, and they mate and produce offspring, do you know what you get? No? We have a donkey and a horse. No? Pony is a horse. What?
A mule.
A mule. Forms a mule.
That's a mule? I thought a mule.
A mule is a hybrid. Now mules cannot reproduce. Okay? They're sterile. So two mules, a male and female mule, cannot produce offspring. Okay? The only place you get a new mule is from breeding a donkey and a horse.
So look at a mule and a mule?
No. They're sterile. They can't reproduce.
What if it was the other way around?
They just can't. They sometimes, you can have it the other way around. Here's another one. And usually they're named after a combining of the two names. False killer whale, a bottlenose dolphin, a wolphin.
So can a mule get a hybrid? Make a
Nope. Nope.
What are narwhals?
That's a lie. You said before.
What? They're just their own species. A male lion and a female tiger?
Liger.
Yeah, so have you ever seen Napoleon
Yeah.
Dynamite? A
I've
liger?
seen a liger.
Yeah, I've seen ligers.
Really?
Zebra and a horse? A zorse? Usually when they make these combined names, they put the male parent's species as the first part of the name. Like a male tiger and a female lion is a tion. Now there's something else. Where did you say liger, Dan?
Liger, I thought it was either Hilton Head or Myrtle Beach.
Yeah, Myrtle Beach, yeah, I'm in one of those places. Usually, often these hybrids are actually much larger than either parent. Like a liger is usually much bigger than a tiger or a lion. Something called hybrid vigor, that they often are much larger. Here's some more. I'll show you. This is a growler bear. This is the growler bear. It's a cross between a grizzly and a polar bear.
How'd they meet up?
What's that?
How'd they meet up?
This is a savannah cat. It's a domestic cat with a wild cat. That's a sheep goat. This is something used in agriculture. This is a beefalo. It's a cow-buffalo hybrid. So you notice these things, this really doesn't happen in nature. So almost all of these happen in captivity. If you take a female, a lion and tiger in a zoo, this might happen. In an aquarium, on a farm. These in agricultural situations. In nature, under normal circumstances, two different species will not interbreed with each other.
Why not?
Because their goal through evolution is to produce fertile offspring and continue the species. And reproducing with another species does not do that.
Wait, what was the last one?
That's a this is a zebra donkey mix.
Zombie? Wait.
That is cool.
Some more.
What's it called?
Oh
Javelin?
my god.
Jaguar.
Killer bees.
That thing looks awesome. I'd buy that.
Killer bees actually killer.
Yes. Was there something else I wanted to show you here? No, I guess not. All right.
Yeah, why are killer whales called killer whales?
Because they are carnivores.
But they didn't ever kill.
Can't have a cat dog.